Hello students, the topic for today's class is binomial theorem. We'll see some concepts related to the binomial theorem and some previous year questions of JEE for it. So, if you have two real numbers a and x, which are the two real numbers, and some n, which is a positive integer, then the expansion of a plus x raised to power n is nc0, a raised to the power 0, x raised to the power n, plus nc1, a raised to the power 1, x raised to the power n minus 1. Will proceed similarly, and ncn, a raised to the power 0, x raised to the power n. So here you can see that the net sum of the power like n plus 0 should be equal to n. N minus 1 plus 1 is equal to n. N plus 0 is equal to n. So the sum should be equal to n for the power in each term. Here nc0, nc1, nc2 and ncn are the binomial coefficients. Okay. The formula for NCR is basically n factorial upon r factorial and n minus r factorial. Let's see some properties of this formula. Like if you have ncx is equal to ncy, then this implies that either x is equal to y or x plus y is equal to n. For example, if you have 10c2 is equal to 10c8. So here 2 plus 8 is equal to 10. That's why nc2 will always be equal to 10c8. And the other properties are like if you divide ncr by ncr minus 1, then the answer would be n minus r plus 1 by r. You can remember all these properties. These will come handy while solving the questions. In any binomial expansion, there are total of n plus 1 terms. Like if you have seen here, we have started with nc0, then nc1 till ncn. So starting from 1 till n, these are the n terms, and this is one more extra term. So the total number of terms in this expansion is n plus 1. Now, if you have to find any general term, like if you want to find some r plus 1th term of the expansion, then we have a formula for it. The term tr plus 1, t denotes the term, so r plus 1th term can be found out as ncr, a raised to the power r, x raised to the power n minus r. So if you are expanding a plus x raised to the power n and you have to find the r plus 1th term of this expansion, you can use this formula. And if n is even, then n plus 1 will be odd. So you have the total number of terms as odd number of terms. So the middle term will be n plus 1 by n plus 2 by 2th term. Since n plus 1 is odd, n plus 2 will be even. So n plus 2 by 2th term will be the middle term if n is even. And if n is odd, then the number of terms will be even because n plus 1 will be even. So then we'll have two middle terms. The first middle term will be n plus 1 by 2th term, and the other one will be n plus 3 by 2th term. This is the case when n is odd. Remember that binomial coefficient of the middle term is always the greatest. Suppose you get a question that you have to find the binomial coefficient which is the greatest, then basically you have to find the coefficient of the middle term. And in this case, where there are two middle terms, the coefficient of both the terms will be same. There is another concept, sum of binomial coefficients. If you have to find the sum of an expansion, if you find the expansion of 1 plus x raised to the power n, then if you have to find the sum of the coefficients of this expansion, you can directly find it out using the formula 2 raised to the power n. So the sum of nc0 plus nc1 plus ncn is basically 2 raised to the power n. Okay. And suppose you are expanding the expansion x plus y raised to the power n, then the total number of terms will be given by n plus 1 c1. So if you have two terms, this will be n plus 1 c1. If you have three terms, x plus y plus z raised to the power n, then the total number of terms in the expansion will be n plus 2 c2. If you have four terms like this, and if you expand this using binomial expansion, you will get n plus 3 c3 terms. These are the number of terms. This is basically equal to n plus 1. We already know that when expanding two terms of expansion, we get n plus 1 terms. Now let's do some questions related to the binomial coefficients. The first question is, find the remainder when 27 raised to the power 999 is divided by 7. So we have to find that what is the remainder when this number is divided by 7. So we can write it in terms like 27 can be written as 28 minus 1. And now if I expand 28 minus 1 raised to the power 999 using binomial expansion, I'll get 999 c0, 28 raised to the power 0 minus 1 raised to the power 999 plus c1, 28 raised to the power 1 minus 1 raised to the power 998, c2, 28 raised to the power 2 minus 1 raised to the power 997. I'll keep on writing 990. C9, 28 raised to the power 999 minus 1 raised to the power 0. Now in this, if you observe that this term has 28, so this is a multiple of 7. This term has 28 square, this will also have a multiple of 7. All the terms after this will be a multiple of 7 because the next term will have 28 raised to the power 3. The next term 28 raised to the power 4. Till here 28 raised to the power 999. All these are multiples of 7. So if we divide this by 7, the only term which does not have any multiple of 7 is this one. Let's see, is 999 c0 is equal to 1. 28 raised to the power 0 is also equal to 1. And minus 1 raised to the power 999 is equal to minus 1. So this term gives us remainder 0 and this term gives us remainder minus 1. Since remainder cannot be negative, so we can write minus 1 mod 7 which is equal to 6 mod 7. So our remainder will be equal to 6. We'll consider our next question. We have to find the sum of the series 20c0 minus 20c1 plus 20c2 minus 20c3 is 20c10. Suppose if you expand 1 plus x raised to the power 20 1 minus x raised to the power 20 you will get 20c0 1 raised to the power 0 minus x raised to the power 20 plus 20c1 1 raised to the power 1 minus x raised to the power 19 plus 20c2 1 raised to the power 2 minus x raised to the power 18. You will keep on expanding like this. You will get 20c19 1 raised to the power 19 minus x plus 20c20 1 raised to the power 20 minus x raised to the power 0. So if I substitute x as equal to 1 in this, what will I get? Here I will get 0 on the left hand side. 0 is equal to, this will be 20c0 plus 20c1 into minus 1 plus 20c2 minus 20c19 plus 20c20. Here my n is equal to 20, so I'll have 21 terms in this expansion. Since I have 21 terms, so my middle term would be 11th term. And or I can also say that 20c0 will always be equal to 20c20, because we know that NCR is always equal to NC n minus R. 20c1 will be equal to 20c19. 20c2 would be equal to 20c18. So I can write it as twice of 20c0 plus 20 minus 20c1 plus 20c2 minus 20c9 plus 20c10, because 20c10 would be the middle term. All this is equal to 0. So from this I get minus of 20 c10 by 2 as 20c0 minus 20c1 plus 20c2 till minus 20c9. If I add 20c10 on both the sides, this will become the question which I wanted to find of the sum of, like 20c0 minus 20c1 till plus 20c10. So if I add 20c10 this side, I'll get the exact same expression, and on the left hand side I'll get 20c10 by 2. So the sum of the given series is 20c10 by 2. Let's look at this another question. We have to find the coefficient of x raised to the power minus 5 in this binomial expansion. Seems very complex, right? But we can simplify it very easily. Let's suppose x raised to the power 1 by 3 is equal to t and x raised to the power 1 by 2 is equal to s. If I substitute them here, first let's consider this first term only. Okay, so if I substitute this here, I'll get t cube plus 1 upon में t square minus t plus 1. So if I multiply t plus 1 on both the sides, in the numerator and in the denominator, this expression becomes t cube plus 1. You know that a cube plus b cube is always equal to a plus b, a square minus b plus 1. So I can write it as t cube plus 1 t plus 1 divided by t cube plus 1. So this and this will get cancelled and you will get t plus 1. Now let's focus on this term. So I'll write it as s square minus 1 divided by s square minus s. So it can be written as s minus 1 s plus 1. If I take s common, s minus 1. So and this will get cancelled. You will get s plus 1 by s. This is equal to 1 plus 1 by s. So my this term becomes t plus 1 minus 1 minus 1 by s, because there is a minus sign here, and this will become t minus 1 by s, which is equal to x raised to the power 1 by 3 minus 1 by x raised to the power 1 by 2. Now since we have simplified this expression, So we got it as x raised to the power 1 by 3 minus 1 upon x raised to the power 1 by 2 raised to the power 10. The question was this raised to the power 10, and we have to find the coefficient of x raised to the power minus 5. Coefficient of x raised to the power minus 5. Now if I see the formula of TR plus 1, which will be equal to NCR, N is 10 here, 10 CR, x raised to the power 1 by 3 raised to the power R, and minus 1 by x raised to the power 1 by 2 is 10 raised to the power 10. This raised to the power 10 minus R. So it is x raised to the power R by 3 minus 1 raised to the power 10 minus R, and x raised to the power minus 1 by 2 10 minus R. So the coefficient of x would be R by 3 minus 1 by 2 10 minus R. So if I solve only this expression, because I have to find the coefficient of x raised to the power minus 5, I will equate it to minus 5. R by 3 minus 5 plus R by 2 is equal to minus 5. So this is 5R by 6 is equal to 0. R is equal to 0. From here I get as R equal to 0. So my T1 would be equal to, if I substitute R equal to 0, 10C0 x 1 by 3 raised to the power 0 is 1 minus 1 by x raised to the power 1 by 2 raised to the power 10. So it is x raised to the power minus 5 and minus 1 raised to the power 10. Since 10C0 is 1 and minus 1 raised to the power 10 is also 1, so we get it is equal to x raised to the power minus 5. So the coefficient of this term is 1. So our answer is 1. Now let's look at this question. If the number of the terms in the expansion of 1 minus 2 by x plus 4 by x square raised to the power n, where x is not equal to 0, is 28, then the sum of the coefficients of all the terms in this expansion is. So this seems very difficult, right? But since we know that if x plus y plus z raised to the power n, if we expand this, the number of terms we get as n plus 2 c2, right? So n plus 2 c2 will be equal to 28 here, because we have been given that the number of terms are 28. So if I expand this, I'll get n plus 2 factorial by 2 factorial, n plus 2 minus 2 n factorial. This thing equal to 28. This implies n plus 2 n plus 1 by 2 equal to 28. If I solve this, I'll get n plus 2 multiplied by n plus 1 equal to 56. N square plus 3n minus 54 is equal to 0. If I solve this using discriminant formula, I'll get minus 3 plus minus under root plus minus 15 by 2. So if I solve, I'll get it is equal to 6 comma minus 9. So n can only be positive because n cannot be negative. So our value of n is 6. We have got n is equal to 6. And since we know that the sum of the coefficients of any binomial expansion is 2 raised to the power n. Sum of the coefficients are 2 raised to the power n. And we have got n equal to 6. So the sum would be 2 raised to the power 6, which is 64. Correct? Now another interesting question. The sum of the coefficients of integral parts of x in the binomial expansion of 1 minus 2 under root x raised to the power 50 is. We have to find the sum of the coefficients of integral part of x. Since here x is in under root, so only the even parts of x will give us integral parts of x. Like if I have 2 under root x raised to the power 2, I'll get it as 2 4x. So only even parts will give me integral power of x. Okay, so we have, how will we proceed? First let's expand it. 1 minus 2 under root x raised to the power 50. This will be equal to 50 c0. 1 raised to the power 0 minus 2 under root x raised to the power 50 plus 50 c1. 1 raised to the power 1 minus 2 under root x raised to the power 49. 50 c2. 1 raised to the power 2 minus 2 under root x raised to the power 48 till 50 c50. 1 raised to the power 0 minus 1 raised to the power 50 is 2 under root x raised to the power 0. So now let's see if we expand 1 plus 2 under root x raised to the power 50. Because in this way, here we are getting these terms with negative sign, because minus 1 raised to the power 49 will give us negative term. Okay, and others as well. So if we take plus sign, then we'll get all the terms with a positive sign. Same terms but with a positive sign. Okay, now if I add these two equations, my equation 1 and the equation 2, what will I get if I add them? On the left hand side, I'll get 1 minus 2 under root x raised to the power 50 plus 1 plus 2 under root x raised to the power 50. And here the terms like this, which have the negative coefficient, like minus 1 raised to power 49, this and this term will get cancelled. Similarly, other terms will get cancelled, and we'll get the terms which have even parts on under root of x. So twice of, no, we can't say twice of, yeah, twice of 50 c0, because this minus sign will become positive because minus 1 raised to power 50, and here there is no negative sign. So these terms are basically same, and we can write twice of 50 c0 plus 50 c2, 2 under root x raised to power 48, 50 c50, 2 under root x raised to the power 0. Right? Even if I substitute x equal to 1 here in this equation, what will I get? If I substitute x equal to 1 here, I'll get 1 minus 1 0, 1 minus 2 minus 1 raised to power 50. If I substitute 1 here, so I'll get plus 3 raised to power 50, twice of this 50 c0 plus 50 c2, 2 raised to the power 48 plus 50 c50. Right? And we have to find the sum of these terms only, because all these are the coefficient of integral parts of x, because here we'll get integral part of x. Like I'll get here x raised to power 24. In the next term I'll get x raised to the power 23. So all these are integral parts of x. We'll get x raised to the power under root x. So we have to basically find the sum of this quantity. So sum of this quantity will be equal to 3 raised to the power 50 minus 1 by 2. This 2 will come down here. So this we get as the answer. Now in this question there is one trick, like you have been given the coefficients of 3 successive terms in the binomial expansion of 1 plus x raised to the power n are in the ratio these. So the coefficients of any three successive terms are in the ratio this. In this expansion, we have to find the first of these terms. So let's suppose you have terms like Tm, Tm plus 1 and Tm plus 2. The ratio of the coefficient of these terms are 1:7:42. Okay, so we have a formula for it, like the m will be equal to a b plus c b square minus ac. So here a, b, c are the ratios. So a will be equal to 1, b will be equal to 7 and c will be equal to 42. So these three are the ratios. So if you have the ratios, you can directly find what is the value of m. So about which terms we are talking about. So if I substitute it here, so I'll get 7 plus 42, 49, b square, 7 square, 49 minus ac, 42. 49 minus 42 is 7. So I'll get m is equal to 7. So we are talking about the T7, T8 and T9. So we have to find the first of these terms. So like you have to find T7. To find T7, you will take r equal to 6 because 7 is 6 plus 1. So we can write T6 plus 1, Tr plus 1 is equal to NCr, NC6, 1 raised to the power 6, x raised to the power n minus 6. So this will be your 7th term. That's what the answer is. The first of these terms in this expansion is NC6, 1 raised to the power 6, s raised to the power n minus 6. I'll tell you another thing, like if you have to find n and you have been given these three ratios a, b, c, then you can directly find n as well, which is 2ac plus ba plus c by b square minus 4ac. So you can get a question also like this to find what is n. So from this formula you can find n if you have these three ratios, and from this formula you can find m, where m is t if the ratio is tm, tm plus 1 and tm plus 2. These were the questions from some previous year JEE papers. You can practice them, and that's all for today. No doubt.